All right, guys, we're going to continue on lesson 7.4 here with part B, simplifying radical expressions. So today what we're going to focus on is simplifying radical expressions by using the quotient property of square roots. So we're going to get into some division with radicals. Yesterday we really focused on multiplication. Today we're going to focus on some division, and then we're also going to focus on some combining of like terms, so some addition and some subtraction. Man, why was that so hard to say? So here we go, guys. The quotient property of square roots for any numbers a and b, where a is greater than or equal to 0 and b is greater than 0. The square root of a over b is equal to the square root of a divided by the square root of b. So here, this is what this is saying: that we can break any radical that is in a fraction form up into two radicals. Okay, the square root of the numerator over the square root of the denominator. But here's the catch. I don't know if you remember this from last time. Hopefully you watched the last lesson and this stuck with you, that if you have a square root in the denominator, that we don't allow. Okay, so we don't allow square roots in a denominator. So today we're going to focus on how do I get rid of the square root in the denominator but still make something. We're simplifying here, so we still have to make something that's equivalent to the original. Okay, so the important rule to remember is you cannot have a radicand in the denominator. There's no radical signs in the denominator. So here we go. Let's look at this. Here's an example that I walked through with you. It says simplify the square root of 35 over the square root of 15. So the first thing you might want to do is you might want to just reduce that fraction. So we know that 3 goes into both of these, so we could divide both by 3 and get 7 over 3. Then we know by the quotient property that we can write that as the square root of 7 over the square root of 3. All right, and then here's what we're going to do to rationalize the denominator, step 3. Okay, so this is kind of the new thing, is we're going to multiply by the square root of 3 over the square root of 3. The reason we're going to do this is if you took the square root of 3 and multiply by the square root of 3, you end up getting the square root of 9. Well, the square root of 9 is just 3. So if you multiply by a radical that is equivalent like this, you end up just getting what's back inside. Okay, because essentially if we take the square root of something, it's like taking the opposite of multiplying something by itself, right? So here, if we have two roots doing that, we're going to get the thing that's inside back. I don't know if that makes sense, but essentially, the square root of 3 squared is just 3. And if we multiply by itself, we're essentially just squaring it. Okay, so we multiply by the square root of 3 over 3, which, by the way, just so that we're very clear, this is equal to 1. Therefore, I'm not changing the value of the whole. Okay, so that's equivalent to 1. That's totally legal to do. I'm not changing any values of the whole. Square root of 7 times the square root of 3 is the square root of 21. The square root of 3 times the square root of 3 is just 3. Now I don't have a radical in my denominator, and I'm done. Now look, an important thing to note here is if you hopped on your calculator and you took the square root of 35 over 15 and you got some decimal, okay, and then you took the square root of 21 and then divided that by 3 and got some decimal, those decimals had better match up. So there's a nice way to check your answer. Okay, so you just plug it in to your calculator and you should be able to get the same decimal. But do not give me any decimals for your homework. Okay, we're focusing on keeping things in radical form because that's important later. Example 4 says, and let me just make sure that this is not supposed to be the square root of 6y. I think it is. So bear with me just for a second here. Yes, so this radical is supposed to go over the y as well. Okay, so it says to simplify this thing, what I'm going to do is, first of all, what I could do is, I see that this is the square root of 6 over the square root of 12. I could reduce the fraction, right? So I could do that now and have the square root of y over the square root of 2. Okay. And I need to get rid of the square root of 2. By the way, if you didn't do that, you can just do that later, so that's not a big deal if you forget to reduce that fraction first off. That's something equivalent to 1. The square root of 2 times the square root of 2 is 2. The reason we do that is to get rid of that radical in the denominator. The square root of 2 times the square root of y is the square root of 2y. Okay, don't try to cancel this because the square root of 2, some people try to cancel that. Don't do that because the square root of 2 and 2 are not the same. Okay, so we can't just sit there and cancel that. So that's example 4. Now, so you'll have some to do like that, some example, some that are like example 4, where you're just reducing these things. Then I need to teach you about this thing called a conjugate, which you will use again and again and again, not only in this lesson but in future maths. And so check this out, you guys. It says, if you hear the word conjugate, think opposite sign. It's used to simplify expressions where there's a radicand in the denominator with a rational number. So look, if you have something like this, let's just say you have something like 3 over what they tell you here, 2 plus the square root of 7. Okay, if you try to do what we just did in the previous example, example 4, right? And you're like, oh, I got to get rid of this, so I better multiply by the square root of 7 over the square root of 7. Okay, if you do that, you got to be very careful there because what you have to do if you do that, you have to distribute that to both pieces. Okay, so catch this because you're not going to end up doing this. I'm going to show you why. If we took the square root of 7 times 2, you get 2 times the square root of 7, or 2 root 7. And if you took the square root of 7 times the square root of 7, you end up with plus 49. But notice we still have this radical here, right? And then we could do 3 times the square root of 7, have 3 root 7 here. If there's a radical in the denominator, that is not allowed. Okay, so how do I get rid of it? I get rid of it with a conjugate. Okay, so let's work this same problem using what we call a conjugate. So you only use a conjugate, to be clear, when there is a plus or minus sign between radicals, or between a radical and a whole number. Okay, so what I'm going to do instead of just multiplying by the root 7 is I'm going to multiply by 2 minus root 7. I always use the opposite sign of what's here. So it's the same thing with the opposite sign. All right, and I'm going to teach you how this works. Now, if you haven't heard of this term foiling yet, I'm going to teach that to you as well. But essentially, if you multiply this guy by this guy, remember that we have to distribute both pieces. So first off, what I'm going to do is I'm going to take 2 times both of those things. When I do that, I get 4, because 2 times 2 is 4. And then I get minus 2 root 7. And then notice what happens here. I have root 7 times 2, which is plus 2 root 7. So what ends up happening is those cancel every single time. And then the square root of 7 times the square root of 7, times negative root 7, I should say, is 49. But there's a negative on the outside there. So it would end up being 4 minus 49. Okay, so in the bottom, in the denominator, 4 minus 49 gives me whatever that is, negative 45. And in the top, we can keep the radical sign in the top. Okay, so 3 times 2 is 6. 3 times negative 7 is negative 3 root 7. All right, so, and then I could simplify that a little further because I think I could probably take a 3 out of each piece. But I just wanted to show you that example of how conjugates work. So let's try one of these, example 5 here. Notice to get rid of that radical, we multiply by a conjugate. This thing is equal to 1, by the way, again, okay, because it's the same thing over itself. So when I FOIL that out, I get 5 squared minus the square root of 2 squared. That's what the pattern always is because the middle terms cancel out, which is just 25 minus 4. Sorry, I should say 25 minus 2, which is 23. And then I take 3 times the top, which is 3 times 5 is 15. 3 times negative root 2 is negative 3 root 2. Okay, and then that's done. So let's do one together. Now this is example 5a. And then it looks like I do one from your homework that I help you with here. So, okay, so here's example 5a. What I'm going to do is, since this has two pieces here with the plus sign in between, I am going to use a conjugate. I'm going to multiply this by 2 minus root 2, the conjugate. Okay, to simplify this. When I do that, again, the middle terms, what the pattern that always arises is you always get the first term squared minus the second term squared. That's the pattern that always arises. But let me just show you by using the foiling method again. If you do square root of 2 times 2 minus root 2, okay, and I foiled it out, I get 2 times 2, which is 4, 2 times negative root 2, which is negative 2 root 2, 2 times positive root 2, which is positive 2 root 2, those cancel, and then the square root of 2 times the square root of 2 is square root of 4, but I'm subtracting, so it's a negative square root of 4. The negative square root of 4, by the way, though, is just 2, so I get 4 minus 2. So on the bottom, I'm left with 4 minus 2, which is 2. In the top, 3 times 2 is 6. 3 times negative root 2 is negative 3 root 2. That is my answer, and I am done. So that's example 5. Let me work number 11 with you real quick on this one. So this is number 11 from your homework. Okay, so another conjugate problem. This is going to be, I'm going to multiply this by 3 minus root 5. I'm at least going to start this for you. Okay, so when I do this, what I end up with is it's 3 squared, which is 9, minus the square root of 5 squared, which is just 5. So it's 9 minus 5. Okay, I'm going to let you distribute the top out and simplify the bottom there.